Hello, everyone, and welcome to this half-an-hour session with the Nordic IoT Center. My name is Anders Madsen. I actually work at Force Technology, as the screen states, but I'm here with Alex, who you see at the picture above me, who's muted right now, but he's there.
Hello.
Yes, hello, Alex. We're Force Technology and the Alexandra Institute, who Alexandra works for, made this joint operation called the Nordic IoT Center. And the Nordic IoT Center is an establishment to help the Nordic countries develop IoT products with the vast ecosystem that lives out there with companies who develop IoT and supports IoT and service IoT and in every way contributes to everything that is IoT. So it's a huge network of people that's very difficult to maneuver in and find out which is the best for your company. So that's what we do. We nurture and help and advise, and also do startup, getting started services for companies who wants to move into to IoT, to the world of IoT. So as our vision states here, it is to make the Nordics the best place in the world to develop IoT-enabled products and IoT-based services. And we do that by promoting and usage of development within the different developers and service companies that do IoT development and services in the Nordic companies. And the reason we think that ecosystems is a good way of going at it, instead of just choosing maybe one, is that you can't have every aspect of everything, the knowledge about every aspect in your company. So finding the right ones to do the right tasks must in the end produce more reliable and better products and services. The Nordic IoT Center right now we have our own little ecosystem, but it isn't confined only to our ecosystem. It's everybody who develop products. So we try to get as many we can into our partnerships, so we can direct customers to them and find the right developers for every customer that comes to us. Right now we have the ones seen here and probably a bit more as well. I think we're around 40 at the time. So first off, we're going to go through what is an IoT system, and this is very rudimentary, but it's going to be just to get everyone up to speed into some of the troubleshooting and some of the models we've made of the ecosystem later on. So it's good to go through anyway. So first off, we have a thing. You don't necessarily need a thing in the first place to start an IoT product. That could be a development that you do at the same time. But a lot of companies who make products already want to IoT enable them. Let's just put some of all of these up there already. So we have a lot of things that's inside this, a lot of parts inside the thing that's necessary for it to work. The microcontrollers, sensors, maybe batteries, storage, and then the user and the digital user, maybe that could be a server. So we have the wireless network. That's mostly what's the enabler for an IoT thing. For a thing, you need to have some data of it that you need to put onto your cloud and to a calculation-based service. And then you, of course, do storage of that data or do some visualization of it. But how we use this in the IoT ecosystem is that there are a lot of parts you just saw, and not everybody might be good at doing the development of that. The companies already know this, and in the past if they have some domain knowledge that some other development companies have, they will go to them. But in order to expand their knowledge of who might be good at what, we are here to facilitate the communication and the partnerships between these companies and the development in the end, for them to maybe they once back then they went to 5 different companies. Now we expand that to at the point 40. At this point 40 companies that they can help in the development to make the best and most reliable products. First off, we wanted to model what is the IoT ecosystem. And to do that, we took a look at all the actors we have and all the partners, and what is their role. Well, role is the wrong word to use right now, but you'll find out why role is the wrong word to use. But we need to find out what is their part in this ecosystem. So whenever we need something to be done, let's say wireless communication, a lot of them can do that, but who's going to do that? We gave them that tag or title or whatever you want to call it. But that's actually the wrong way, because even though they might not be good at everything, all of them, they are most certainly good at way better than more than one thing. So we wanted to do this as a more thing-centric thing instead. So when we wanted to model it, we wanted to look at what is actually there to be developed. You saw all the things here. Instead of looking out from this to on the developers, we looked from the developers in at this. So we defined all the roles. So it's going to be a role-based model instead of an actor-based. What's necessary, what's there to support, who's there to use an IoT system, who's there to develop the different parts of an IoT system, who's there to promote, to finance it. All the roles that's necessary in an IoT ecosystem, or to support an IoT product in an IoT ecosystem. So yes, we turned it to a things centric instead. So we have these 4 categories of roles. Well, technically 5, because we also have the product manufacturer, who is actually the customer of the Nordic IoT Center that we distribute out to the developers. But that's not really the role that's already defined as one person or one company in the first place. So we have the IoT and governance and support roles, which is all the financing and legislation and so the FN goals is also something that would be put up there. If that's the reason why you're developing your IT system to live up to the FN goals, that's also defined up there. Then we have the usage roles. That could be, say a medical device that's not used, that is used by the medical person, but like a nurse or something, but it's not, the beneficiary of that product is not really the nurse necessarily. That could also be the patient. So you have 2 usage roles there, both the nurse and the patient, even though it isn't the same role. So there's more than one user of an IoT product. That could be also a service company. They technically use it, but they aren't necessarily the beneficiaries of that product. That might be you who's subscribing to that service. Then we have the operation roles. That could be service people, computing, and in any way someone who provides a what do you call it? Something that's consumables in both, basically something that's used up as the product or the service is running. And then we have all the development roles who develop either the software or the hardware and stuff. But these are the basic 4 overall roles that we have. We can expand that a bit. So we have in the middle here the product owner, as we talked about. Then we have all the mechanical and the electronics that we just talked about, and test provider, which could be force, just saying. And then we have the component suppliers and yeah, the developers of who use these together. Then we have the software side, and the data solution developer could be Glaze. And then the data broker. The second role category is the service. As I said, support and service, computing provider, network service providers, TDC3. And the users, as I said, the distributors, the utilizer, and the end user. So the guy who sells this IoT solution to the nurse who uses it, and the patient. So where we come in as the Nordic IoT Center, it could be us, it could also be some of the others. Whenever some of the other partners, whenever a company comes to us and wants to develop a service, we put on the hat of the IoT contractor or the IoT client advisor, mostly the client advisor, and then we help you navigate through what developers it is that you should use, and what suppliers, and what computing providers, and what network services you should use for your case. Because all in all, we want to develop the right product, not necessarily just the one that makes the most profit. It is about more reliable products than it is about profit. Yeah, and that could all feed back. So maybe we make some products that is then used in the same iteration again. So it is more of a spiral than it is a loop. And here we have all the governance roles as well. The standardization providers, and the financiers, and the IoT value demonstrators. We also have a lot of these hats, and the Alexander Institute has a lot of these hats on as well, as you see here. So when we've developed a product that's to be rolled out into the market, we can also use the IoT ecosystem to help with whatever problem might arise on some already installed IoT products, because domain knowledge is important in troubleshooting. You have processes to do this, but if you search around processes, there are very domain specific as well. So you need the technical persons, people who are working with whatever IoT product failed, or system, or if a what is that called, a factory breakdown. You need the right persons, the ones with the domain knowledge to search for it. So we utilize the IoT ecosystems for this as well. So we came up with a troubleshooting process, talking about domain specific. We came up with an IoT troubleshooting process that's based on several standards. First off, the IoT reference architecture, and that's spelled wrong actually, architecture, and then the root cause analysis. And then of course it's based on the Alexander Institute experience, and the Force technology and experience, and our broad and very deep knowledge into a lot of knowledge areas. I'll bring this up in the end because I think we might have some questions for this, but we can go into a deeper dive in this in the questions in the end, because I could use maybe an hour in this alone. So we're going to go ahead with some of the terminology. That might seem well, secondary to go through the terminology, but a lot of the terminology actually defines a lot of the steps you need to go through. And it'll, if you know all the names of the terminology and the meaning, you know what to ask for, and how to dive into the problem to find the right cause. Because it is the first thing we need to find is the cause, and then we can always come up with a solution. That's not always the difficult part. It's mostly finding the problem. That's the problem. So we have focus event, symptom, failure mechanism, cause, causal factor, root cause, and stopping rule. The focus event is something in time that has happened that then changed the function of your system, to keep this non-specific. And then we have the symptom. That's of course what you experience, say a virus, very up in the time right now. The coughing might be your symptom. Or if a coffee machine breaks down, no coffee is the symptom. Then we have the failure. That might be the grinder in the coffee machine breaking down. So no grinding of coffee is then the failure. The failure mechanism is then the engine or the motor in the coffee machine not working. The cause could be the short circuit in the motor. The causal factor could be something got stuck in the, too much resistance on the blades. And then the root cause is then, of course, that the blades weren't sharp enough to cut the coffee, if you use that kind of grinder, of course. So now we can come, so the stopping rule is then that we can now say we've found the actual cause of why the whole thing broke down, even though it took us several levels to get there. So the terminology here defines how many levels you have to go through, at least and some of these you have to go through several times. There might be a lot of causal factors, there might be a lot of causes, but not all of them might have been the trigger, like, you know, the last droplet in the glass. So here is an example of a focus event. We have a power plant emergency shutdown. So something changed in time. The shutdown went off. We have too high vibration levels in the turbine. It's a symptom. So we can see that the sensors is saying there's way too much vibration in the turbines. We have a vibrational sensor reporting, that's the failure, vibration in the turbine. The failure mechanism is too much electromagnetic noise induced into the sensors, so it's actually reading wrong. But the cause of the vibrational sensor not immune to the magnetic fields that it's subjected to. And the causal factor is, of course, that there's a lot of magnetic noise in this place, because regular levels it's probably tested for in the CE marking. The root cause is the sensor is not immune to the levels at the present at the sensor. The cause is that it might not be made for this type of environment, or there's not enough reduction of the magnetic fields in the factory or power plant. So that's all the different, what do you call it, findings we need to do to get to the bottom of a failure, or of a breakdown, or whatever it is that you experience in you need troubleshooting for in an IoT system. Of course, we have a lot of tools, and this is probably where you might have some questions, and especially questions for Alex. We're going to come into that in a minute. But we have a lot of tools that we use at the different phases and stages of a IoT troubleshooting. First off, we need to go into the detail with the customer and analyze what they experience, because it might be, of course, you have logs and you have electronic logs, and they are accurate in the sense that what they see is what they report. Other than a human being might not be reporting what they actually saw, because, you know, they can forget and interpret stuff differently. So if you have a human log, it's not necessarily always the same as the human log next to it, but the sensor input in a human log can sometimes be more than an electronic. So we need to do interviews, and we need to get all the knowledge from the customer who's experiencing this problem, And we have different tools for that as well. First off, we have the 5 whys. Some maybe know this. And actually, Alex, you told me once that the kids go through 7 whys usually in the yeah, you know, when they ask why to everything, they stop usually at 7. So I don't know why this process stops at 5 when the nature obviously wants us to do it at 7.
We have grown a bit more
Yeah, maybe that's
efficient.
why. Yeah, maybe that's why. But you can actually see an example here where how useful it can be, because a garbage truck breaks down. It wasn't sent to a garbage can. Why? The filling level did not indicate that the can was full. Why? Fill level data arrived after the route planning was done. Why? Fill level sensor does not send at the right time of day. Why? Fill level sensor report time is not set correctly in the firmware. And I could actually keep going at this point, but I feel it's sufficient at some point that you can. Of course, this is not all that we do, but you get to a certain point where the course will revolve around the same thing. So you have found, okay, it is because of the firmware. Okay, yeah, the guy didn't set the firmware. Now, why didn't he set the firmware correctly? Well, he was sleepy at the day, but it's still revolving around the firmware wasn't set correctly. You can then talk about maybe finding a different technician, but or maybe make him sleep more. But in order to fix this, we need to set the firmware. So tools for data collection. So that was, of course, like a physical problem. In a sense, it is, of course, firmware, but it was on a device that didn't send. What if we have a failure in a server environment, which is more of Alex's area of expertise? But we have an IoT system here and a data flow model of it, where we have the sensor nodes. You can probably see my mouse, I hope. They're out here on the left, the small dots, and then we have the gateway, and then we have the raw data in the server. We have some filtering and payloading, decryption and cleansing and cleaning of the data, so we can use it. That we might get rid of some of the metadata. Of course, we save a raw data log, but for usage, we need to get rid of the metadata. And then we have the composition where we use the data, and then we have that product finalized for user interface or utilize interface or an analytics or an API maybe. So in this data flow, searching for errors in here is a lot about like searching for it is a lot about comparing the data on the timeline of flow through the server. So we can go in at several points. We can put up a clone gateway to catch all the packages. Let's say it's the LoRa system. We can put up the same gateway right next to it and get all the same packages. So we have the raw data before the server even gets it. So if there is a problem from the backend to the server, we'll see it when we compare the gateway to the raw data. But you can keep going, because you can just from compare gateway to the user interface, and then you narrow it down until you find where the problem is. And although the yellow variables here is some of the methods that we can use to detect outliers and changes in data at the different points. Yeah. So tools for data collection is, of course, the one that I just showed you, but can also be something physical. It could be electromagnetic noise, and if your factory don't have anything to detect this, it might show up as a lot of different weird errors that indicate something that it's not. And I usually try to make a joke with Alex that it's like a French electronics car. Alex is French, so it's funny because he doesn't like it. But an old French car that gives a lot of different errors. But the combination of 5 different errors might meet something 6th, which is usually what happens with EMC. So we put up a lot of measurements. That's what we'll do a lot in Force. Put up a lot of measurements for the different failure mechanisms and try to narrow it down to what might be the problem. Visual inspections with microscopes. If it's a big, huge beam that breaks, we look at the fracture to find the problems in and what forces might have caused this this fracture. And of course, as I talked about, the 5 whys and the interviews that we do with the customers who is experiencing this.
Anas, may I give an example of anomaly detection in ecosystem?
Yeah.
I don't know how many slides you have left.
4.
Okay.
Well, 3.
So let me hurry with an example. So some of those analysis methods can be just as well as applied on one specific product or one specific customer. But there are some things that are also special when IoT projects are done in ecosystem, which means more than one company involved in providing a full solution, a full IoT solution.
Yeah.
A quick, easy to understand, I hope, examples that we observed internally some months ago. A customer which tells, oh, there is no data on the dashboard. So the customer called the dashboard guy. Your dashboard is broken. There is no data. So the dashboard guy tests that and everything is working fine. I can receive data from other sensors, no problem. So then the customer calls the sensor guy and says, okay, but your sensors is broken. The dashboard guy says that it's working fine with other sensors, so it must be yours. The sensor guy tries connectivity, etc. Everything is fine. And you see the pattern there. Everybody is throwing the ball back at someone else, and it's difficult to find what is the actual problem. And this might require a bit of cross-disciplinary expertise to actually find out what is the actual problem and who is able to fix it. So in that case, the actual problem was a handshake certificate problem at HTTPS level, where it was not the same subset of HTTPS requirements from the sensor side and from the backend side, which makes that the sensor could talk to everybody except that specific dashboard or backend, and the backend could receive data from most sensors, just not that specific sensor. And coming to that precise conclusion requires to look at different logs and different approaches and to have a bit of cross-disciplinary expertise, which is what we try to provide in this setup.
Yeah, and in the Nordic IoT Center.
Yes. So we have 1 minute left.
Yep. And yeah, so well, basically you can just continue on this because that is mostly your slides.
Exactly. So we are quite interested in analysis to find anomalies in data. So we can plug ourselves at different levels, and we have a number of tools to start with some standard data analysis, which can then be customized for some specific use cases, where we find correlations in data and have quick views to find out how the data pattern is evolving over time, and which makes it easy to find anomalies. Yes, for instance, when there are missing data where Anas's mouse is, but also when there are some changes in the pattern of packets. For instance, their size might change, the type of payload signature might change, etc., which allows having to a quick filtering of when there is a big volume of data to focus our analysis on a specific area. And
so this is technically a focus event. Something might have happened here that changed time. Yeah. Yep. So if you can take a look, if you are interested in developing an IoT system and what the Nordic IoT Center is about, we have a huge variety of cases at our website with all the different partners that we have already, and some of their genius cases and products that they made. And
I've posted the link in the chat.
Yeah, there's also a link at the end of the presentation. But yeah, and yeah, in there you can see how we nurture and help in development of IoT products, which is basically what I'm here to say about. And we also have some publications of mostly some of the what we've talked about today, but also our IoT Trust Assurance guideline, which is a checklist for you can go through. You don't have to take off everything. It's more of because so far no one has been able to live up to everything we have in there. But it's more of a system for you to expand your own knowledge around your own product. Have I thought of humidity? Yes, I have. It's no problem because it's installed inside. Well, then fine, go on. But it's just to show you a lot of areas that might be of interest when developing a physical and a virtual product, which are often an IoT system is both.
And we will deploy an online form for a quick check, a quick assessment. So
Yep.
stay tuned on Nordic IoT website for more interactive tools about that.
Yes. So we will make a light version of an interactive light version of the IoT Trust Assurance guideline, because it's 400 questions as it is right now. But yeah. So thank you all for listening. If you have questions.
And feel free to reach out for questions and comments and potential projects afterwards. I have posted a link to an online survey in the chat. Please take a minute to, it helps us tuning our services to better help IoT companies, both on the ones offering IoT, but also the companies wanting to consume IoT.
Yes.
Thank you for now.